Hey everyone, welcome to today's review lesson. So in this video, we will be reviewing how you multiply and divide rational expressions. So you've already done some work with adding and subtracting. So you've actually done the hard part. And now we're going to talk about multiplying and dividing, right? You've also done some review just working, I spelled that wrong, just working with fractions. And that was purposeful so that you have some recent memory of what happens when you're multiplying and dividing fractions, right? Because that's going to relate pretty closely to rational expression, to the process for rational expressions. So before we get into this, let's talk about some like specific prerequisite knowledge that you have that we're going to be pulling on. So the first one is you have experience multiplying polynomials, right? Whether that be you're multiplying something like x plus 2 times x minus 3, right? Like double distribution. Some of you guys remember the acronym FOIL. You're not actually foiling, it's double distribution, right? Or you're multiplying something like 2x minus 6 times x cubed minus 4x squared plus 2x minus 9. Right? Like you're just distributing the 2x to everything, the 6 to everything, the negative 6 to everything, right? You have experience multiplying two polynomials or even more, right? That's going to be an important thing to remember, that you're not just multiplying the first two. Even something like this, x plus 2 squared, right? We know that that's equivalent to x plus 2 times x plus 2, right? None of you out there are distributing that squared. You also have experience multiplying and dividing fractions, right? So knowing that something like, even like 2/3 times 6, right? 2/3 times 6. Oh, I could write this as 6/1 and think about it like 12/3, right? Which is just 4. But maybe some of you guys out there are thinking, oh, well, I could change this to 2 and 1, and then it's just 4, right? 2 times 2, I would just get 4. Right? Like that's a good thing to pull on. You also know about dividing fractions, right? And we've done this. I feel like we did this some of the time when we were dealing with, why can't I think of it? Composition, right? A little bit earlier this year, where maybe you had something like 2 divided by 1/2, right? And we were finding domain, right? Oh, that's the same thing as 2 times 1/2. Oh, no, it's not. Oh, goodness. 2 times 2/1. Right? Instead of dividing by a fraction, multiply by the reciprocal. Right? Okay. And then factoring polynomials, everyone's favorite, right? So thinking about having common factors, right? Like you're looking for a GCF or a greatest common factor. Are they quadratic trinomials? Right? Whether the coefficient is 1 or it's greater than 1. Factoring. Difference of squares. Right? If you've got something like 4x squared minus 36, recognizing that that's 2x minus 6, 2x plus 6. I probably should have recognized a little earlier that I could have factored out a 4, right? 4 times x minus 3 times x plus 3. And then, or are we factoring by grouping, right? Can we factor something out that's common? Okay, so it's some of the prerequisite knowledge that we already have that we're going to be pulling on as we go through this lesson. So our objective, I will use knowledge of factoring polynomials and basic operations with fractions to successfully simplify rational expressions with a focus on multiplying and dividing, right? So there you go, factoring polynomials. Expressions. We aren't, and yesterday, same thing, right? You weren't dealing with equations. Like you're not solving anything. You can't move something from one side to another, right? It's not an equation. There's no equal sign, right? I'm never going to end up with, say, like x equals something. Like not now, not right now. Okay, so keep that in mind as well. All right, so let's take a look at this first example. multiplying rational expressions. So pull on some of the things that we did with adding and subtracting. What was the first thing that you did when you approached it? Your steps to success we just reviewed, right? Let's go ahead and factor. Let's see if we can cancel any matching factors. And then let's go ahead and expand, okay? Be careful. That's not okay. You can't do that, right? You can't do that. You know that you can't do that. That's just like you saying something like 4 plus 6 divided by 4 minus 3. Is that, can I do this? Is that 6 over negative 3? Is that just negative 2? No, you know that, right? If I were to actually do this, if I gave you this, I bet like most of you would say, oh no, that's 10 over 1, which is 10. They're clearly not the same. You can't do that. Be careful. That's a very common error. All right, we got to go ahead and factor first. So let's see. I went ahead and factored already. X minus 3 times x minus 2 divided by x plus 6 times x minus 1, and then times x plus 6 times x plus 1, x minus 3 times x plus 2. Right? So cancel any matching factors. I'm multiplying. I mean, I could really stick this over one fraction bar and not even worry about, like, this is just multiplication, right? I don't need a common denominator, right? Look at some stuff that cancels. Cancel. Cancel. Anything else? No, right? So let's go ahead and expand that, right? And this is our answer here, right? We could take it a step further and say, well, x can't equal to 1 and negative 2, right? That's what would make the denominator 0. That's a good thing to keep in mind, right? What are the things that can't equal 1 and negative 2? When you are dealing with dividing rational expressions, it's really just multiplication, right? So leave the first one, change the sign, flip the second one. Instead of dividing by a fraction, multiply by its reciprocal, right? The reciprocal of 2/3 is 3/2. So in this one right here, I can go ahead, and I can leave the first one. I realize I made this too hard. X cubed plus y cubed divided by x plus y cubed times x squared plus 2xy plus y squared divided by x squared minus xy plus y squared. Right? And then we can go ahead and factor. So these are actually, let's see, do we know this yet? No, but that's okay. That's okay. I'm going to still show you. I'll show you what that factors into. So that's sum of cubes. So it's going to be x plus y times x squared minus 2xy plus y squared. I messed up. There's no 2. And then divided by x plus y cubed times x squared plus 2xy plus y squared. Oh, that factors, isn't it? Isn't that just x plus y squared divided by x squared minus xy plus y squared? So to back up a second, not a big deal if you didn't know how to factor this. This is sum of cubes. You can look it up. We haven't reviewed it. So I just told it to you, right? So like this is what that factors into for sum of cubes, right? So please don't stress if you're like, oh my God, I couldn't factor this one. This, yeah, let's factor it. Right? Think about that form. You can totally guess and check. It's got to be x and x and y and y. You know that. Right? It works the same way as if it were numbers. This doesn't factor, but check this out. These cancel. What happens here? Isn't this just, when I multiply these two together, don't I just get x plus y cubed over x plus y cubed? Oh my goodness, isn't that just 1? Right? Pretty cool, right? So division and multiplication, it's the same scale in there. Okay? So this is your brief review. You're gonna keep moving and you're gonna try the problem on the next slide. And then I encourage you to watch the video key on that, right? And keep progressing through this. There's a lot of practice in this review today, so make sure that you have a solid understanding of it. And as questions come up, please ask them, but please keep trying, and please make sure that this stuff ends up in your notes. And if you need to go back and rewatch this again, feel free to. All right. Thanks, everyone.